Here we have AP calculus AB problem. Okay, let's go to the question. If four subdivisions of 1, 3 are used, what is the trapezoidal approximation of integral 1 to 3 square root of x cosine x times dx? Okay, first let me write the formula to get a trapezoidal approximation of a different integral. Okay, let me write the different integral, that is integral a to b f of x dx, and the formula to get the trapezoidal approximation of this definite integral is delta x divided by 2 times f of x naught positive 2 times f of x1 positive 2 times f of x2, and it keeps going positive 2 times f of xn negative 1 positive f of xn. Okay, so this is a formula we have to get trapezoidal approximation of a different integral, and here there is a formula to get the value of delta x. So delta x equals to, so we have to subtract the lower limit of the integral a from the upper limit b, then we get b negative a. It has to be divided by the number of subdivisions. So usually n represents the number of subdivisions in the formula over here. Okay, now so x naught is the first value of x, or it's a lower limit of the given definite integral. That is, a is the value of this x naught, and this xn is the upper limit of the integral, that is b. Okay, here inside the square bracket, except the first one and last one, so each value in the middle has to be multiplied by 2. Okay, now let's compare the integral we have over here and the integral we have in the problem. So at the place of f of x, what do we have over here? So we have square root of x times cosine x. Let me write the stuff over here. F of x equals to square root of x times cosine x. And also the value of a is 1, that is the lower limit of the integral, and b equals to 3, and n equals to 4. N represents the number of subdivisions. So here the question says 4 subdivisions. Now let's find the value of delta x. Delta x equals to b negative a, that is 3 negative 1 divided by the value of n is 4, then we get 2 divided by 4, so which is equal to 1 over 2. And also we must be knowing the value of x naught. We know that x naught is the lower limit of the integral. So x naught is just 1. Just a moment, let me draw a number line over here, and let me take x naught as the first value, and the last value must be x4, because we have 4 subdivisions according to the question. So in that case, when I take x naught as the first value, then the last value of x has to be x4, since we have 4 subdivisions. Okay, now in the middle we have x1, and here we have x2, and here we have x3. Already we know that x naught is the starting value of x, that is the lower limit of the integral, that is 1. Now to get the value of x1, what we have to do is we have to add the value of delta x to the first value 1 over here. So when I get this value as a decimal, it will be 0.5. So that is the value of delta x 0.5. The 0.5 should be added to this 1. Then I'm getting 1.5 as the value of this x1. Now to get the value of x2, I have to add 0.5 to this 1.5. Then I'm getting 2. Again, when I add 0.5 to this 2, I'm getting 2.5. When I add 0.5 to this 2.5, I'm getting 3. So which is the upper limit of the integral over here. Okay, now we can write the trapezoidal approximation of the given definite integral, that is equal to delta x divided by 2. So we have to use this formula. So delta x already we got it, that is 1 over 2 divided by 2. So let me take denominator 2 over here, and f of x naught, for x naught we have 1, that is f of 1 positive 2 times f of x1, that is f of x1 means that's 1.5. Then positive 2 times f of the second, the next value of x, that is 2, positive 2 times f of the next value of x, that is 2.5, positive f of 3. So except the first value and the last value inside the square bracket, I have to multiply each of the middle value by 2. So the first value is kept as it is, the first value of the function f of x. The last value of the function f, that is the value of function f of 3, is kept as is. So in the middle, each value is multiplied by 2 over here. And now we can consider this 2 as a fraction by taking a denominator 1 over here. Then I'm getting 1 over 2, and I can change this division as multiplication. Then we have to get reciprocal for this 2 over 1, that is 1 over 2. And now to get the value of f of 1, we have to plug in x equals to 1 into the function f of x over here. Already we got the function f of x by comparing this one and this one. We got that f of x equals to square root of x times cosine x. Now to get the value of f of 1, let's plug in 1 for x over here. Then I'm getting square root of 1 times cosine of 1 positive 2 times. To get the value of this one, we have to plug in this 1.5 for x over here. Then I'm getting square root of 1.5 times cosine of 1.5. Now to get the value of this 2 times f of 2, let's write this 2 as it is. To get the value of f of 2, we have to plug in this 2 for x over here. Then I'm getting square root of 2 times cosine of 2 positive 2 times. Now to get the value of f of 2.5, I have to plug in this 2.5 for x over here. Then I'm getting square root of 2.5 times cosine of 2.5 positive. To get the value of f of 3, we have to plug in 3 for x over here. And here then I'm getting square root of 3 times cosine of 3. Okay, let me close the square bracket. So here 1 over 2 times 1 over 2 will become 1/4. So here square root of 1 is just 1. 1 times cosine of 1 is cosine 1. 2 times, and here square root of 1.5 can be written as it is. Let me write it clearly. Okay, so then we get cosine of 1.5 positive 2 times square root of 2 times cosine of 2 positive 2 times square root of 2.5 times cosine of 2.5 positive square root of 3 times cosine of 3. Okay, now I got the trapezoidal approximation for the given definite integral. So we find this stuff exactly in answer choice D. The correct answer choice for this question is D.